Okay, question number 33. A metal wire has a length of 2.5 meters. Length L is given here and the cross-sectional area A is given. Resistivity of the metal rho is given. Okay, the wire is stretched so the length is increased to 2.65 meters. So this is your L1, this is your L2. Okay, the wire remains cylindrical and the volume of the wire remains constant. What is the change in the resistance of the wire? What is the change in resistance of the wire? So what we know is that R is equal to rho L divided by A. Okay, and from here we can also write delta R by R is equal to delta L by L plus delta A by A, because what's happening here, wire is stretched and this wire remains cylindrical and the volume of the wire remains constant, which means what, if L is increased, definitely A should also change, right? How does the value of A change? That's what we need to find. Okay, now we know that L into A is equal to V. So delta L by L, L into A equal to V, or L is equal to V by A. Okay, so delta L by L is equal to delta A by A, because delta V by V is become 0, so I can write like this. See, you can always argue saying that, see, if I would have taken delta L into A directly here itself, then I would have written delta L by L plus delta A by A equal to 0, delta L by L equal to minus delta A by A. That could have been done, right? Why didn't I do it? The reason behind this is because, see, whenever you are estimating any error, see to it that whatever you are estimating, that should be considered as subjects and the variables that it depends upon should be on the right hand side. Okay, that's the rule. So as a result of it, we take like this, so that none of the variables now get a negative error over here. We're not getting the negative error over here. Okay, now we got this expression, we will plug in this value over here. When I do this, what do I get? I get this as 2 times delta L by L over here. Delta L by L, and this delta A by A is also delta L by L. I'll put this delta L by L once again for this also. So I get 2 times delta L by L. So thus delta R, that's what I need, which will be equal to 2 times delta L by L into R. And what is R? R equal to rho L by A. Let us substitute that also. 2 delta L by L into rho L divided by A. L and L goes away. So I get 2 times delta L rho divided by A. Okay. Now what's the next step? Just need to substitute. Okay. There are many methods to solve this example, but this is one of the methods I would like to solve with it. 2 into delta L. What's the value of delta L? Delta L is initially 2.50, finally it is 2.65. So I make this as 2.65 minus 2.50 is 0.15 multiplied by the resistivity. What's the value of resistivity? Resistivity value is 3.5 into 10 to the power minus 7. 3.5 into 10 to the power of minus 7 divided by area. What's the value of area? Value of area is 4.5 into the power minus 6. Substitute that value also. 4.5 into 10 to the power of minus 6. So let me use my calculator to find out what are those values. Calculate this. So this should be 2 into 0.15 multiplied by 3.5 divided by 4.5. I get the answer 0.233. 0.233 into 10 to the power of, see, here it is minus 7, here it is minus 6. It comes out, it becomes minus 1. This is nearly 0.0233. This is nearly 0.024. Okay, your delta R should be 0.024. Answer is B. This is one method. There is one more method to do it. That method is that first find out what is the resistance here. Okay, using R1 is equal to rho L1 divided by A1. What is rho? Rho is given here, L1 is given here, A1 is given here. Substitute these values, get the answer. Second, what to do is, we know that L1 A1 is equal to L2 A2 because volume is not changing, right? So I can now write A2, the new area A2 is equal to L1 A1 divided by L2. I can write like this. Okay, L1, what is L1? 2.5. What is A1? 4.5. Sorry, area is 4.5. And what is L2? 2.65. I'll get the value of A2 also here. Then once again, what I'll do is I'll find out R2. R2 is equal to rho times L2 by A2. I'll get this also. Then I'll take the difference between these two. Okay, this is the second method. This method is not suitable for 1 minute answer, because you know, in 1 minute you have to perform this calculation, this calculation, this calculation. So I don't prefer by this method. I go by the error analysis method. But if you are interested to do with this method, you can still prefer with it. You get the same answer once again. Okay, try it out and mention me in your comments whether you are getting the same answer or a different answer. And if you are not getting the same answer, then let me know. Okay, I will try to work it out and give you the same answer. Okay, thank you.